Good morning, Year 10s. It's nice to see you on this bright and cheerful Tuesday morning. Guys, you can all say hi on the chat. I'll do the register. That would be grand. Just waiting for my other laptop to sort itself out. Just waiting for it. Oh, big delay on it today. Oh, there we go. That's very interesting, you see. So for me, that puts me at about something like a 20 second delay. Right, guys. How's it all going? We're going to be finishing off our equations homework, guys, so you can input your data. I need people to input their data. Not all people have done that yet. I'll just quickly send a message on the chat. Hey, Year 10s. So I've got 7 people waiting. Ah, there's Kate. Hi, Kate. Hey, oh, look at that. Everyone's appearing. Hey, Adri. Hey, Timon. Hey, Oleg. Right. Okay. And then I'm just sorting out stuff. More on to. I'm just trying to sort bits and pieces out. There we go. I'll start doing the register now as well. Yeah, let's give that. Okay, so isoms. How we getting on? Got Fatima, yay! Got Chiman, got Kate, I've got Amber. Is Amber? Yeah, there's hey Amber. Nice to see you. I got Zihan. Anyone seen Zihan? No. Natanya? No, Natanya yet. She always tends to be a little bit late. Got Adri. Ethan? No Ethan yet. Boyang. Got Mary. Hi Mary. Lovely to see you. Have I got Ryan? No Ryan yet either. Got Oleg, got Mary. Ah, we're doing okay. 7 so far with 5 to go. Has everyone had a really nice long weekend? It has been so nice, hasn't it? Thursday till Monday. What a weekend it's been. Obviously, the extension to the CMCO is going to put a little bit of a downer on things. But, you know, yeah, we just get on with things. Get on with things. Right, I'm gonna start in 1 minute's time. Let's see if I have Zihan, Natanya, Ethan, or Ryan appear. Otherwise, I will get started in less than a minute. So we can just finish off our review of the balancing equations homework. I'm also, just whilst you guys are all there, I'm just going on to the spreadsheet that I created for you guys. Does anybody need me to reshare this? Because I know that I think that's Ryan has just appeared. Is that Ryan? Pretty sure that's Ryan. Feel like I know that that's. And there's Natanya. Hello. There we go. Amazing. Just Ethan and Zihan to go now. Is that raw? Thanks for that, Truman. Thanks for letting me know it is Ryan. That's good. I'm just quickly going on to the spreadsheet that I created. I'm just checking that you guys have put in all your data. That's all I'm really doing. It would be nice for all my data to be complete. I'm already seeing that there are spaces there. I'll reshare with people. So Amber, you haven't put in your first homework score. Chimon, you haven't put in the last 2. You haven't put the RMM and the RFM and the percentage composition. Bo Yang, you have put in no data. Ryan, you have also put in no data. Yeah, I'm going to reshare it with you guys again, just so you don't. I love the fact that I have other people on here with me. That's great. Fatima and Adri, I think, are there. There's Amber. You guys are awesome. I'm going to reshare this with you, Bo Yang. Because Bo Yang and Ryan, you have not inputted any data yet, and it does need to go in. Ryan, I can't remember what your surname. Ryan? What was your surname? I can't remember what your surname was. Oh, Ethan's in the house. Amazing. Ryan, what's your surname? I think it's so. see if I can find you, Ryan. It's not there. Ryan, surname is, yeah. Are we going to discuss the homework? Yes, we are. We're going to quickly go through that again. Ryan, I wonder why it doesn't come up with, oh, I found you. Oh, send. Right, I've reshared. Oh, it's nice to see that all the data's going in. Oh, it says that you're not part of the, I've sent it anyway. Sent it anyway. Thanks, guys, for entering the rest of that data. That's great. Bo, Yang, and Ryan, you're the only two who have yet to submit any data. Everyone else is nearly complete. Zihan has a third one, and we're going to finish off equations today. Right, let's crack on. I know that Zihan's not here yet. I'll mark him as missing for the time being and then redo it if I need to. But otherwise, let's crack on, shall we? Share screen. Amazing. Sorry, it's taken us a bit of time today. It's taken us a good 7 minutes to get that all sorted. Right, there we are. Right, so let's go to double award. This is where we left off last lesson. So we're going to finish that off today. Anyone that needs to ask any questions on the chat, please do. You guys were really good at that. You guys have been fantastic. Since I picked you guys up a few weeks ago, you guys have been brilliant. It'll be nice just to see this continue. Keep asking questions on the chat. Right. Okay, so draw. Let's see if we can get on with this, shall we? I'll plug in my laptop just so I know that it's not going to die on me halfway through. Right, okay, folks. So we finished off the task 1, and we were going to the medium difficulty. Yeah, medium difficulty. Just going to check that you guys can see everything. Yeah, you guys are all there now. And it says change to symbol, of course, and balance. So they've given you a really nice hint there. It's really nice that they've said symbol and then balance. State symbols are there, so we can also include those. But Cu brackets S is the state symbol for solid. Now, here's the important bit. Yeah, we recognize that any elements ending in ene or gen are going to be diatomic. So that's going to be O2. Yeah, and then it goes into the gas symbol. And then we're going to form copper. Now, this, by the way, can I just point out, the internet is full of really great chemistry, but it does also have some idiosyncrasies that just need a discussion. That, of course, there is incorrect. Yeah, that is not right. Copper is a transition metal, Roman numeral. The proper words for this, the proper words should have been copper. I'm actually going to shrink my pen down a bit. Copper 2 oxide. I apologize about that. Can I just say, by the way, a good rule of thumb, even though you should never have to deal with this, a good rule of thumb in chemistry is if you have a transition metal with no number, it's probably 2. Yeah, the only one that breaks that rule is silver. Yeah, silver is a +1, go figure. So this is going to be CuO as a solid. Yeah, and it's always nice to talk about this as a practical because copper metal is pink. Copper metal is pink. It's a pink metal. Yeah, there we go. It's a pink metal. And then when you heat it, it becomes black. It's one of those really important ones that Edexcel desperately want you to know. Yeah, when you heat it, I can't do that. Lol, that's funny. When you heat this, it'll turn black. Yeah, because copper oxide is a black color, and you have to know that one. And the great thing is, it's not quite balanced, but it's not a difficult one either. Let's balance it. I've gone and ruined that, haven't I, by doing all the stupid lines on it. So 1 copper, 1 copper, 1 copper, 2 oxygens, 1 oxygen, double that one. Yeah, gonna get rid of all those as best I can. There we go. 2. Right, now I need to go back and change my copper, and I'm done. There you go. There's the end product. Sorry about all the colorful scribbles. Ignore those. Next, potassium metal, K solid, plus water, H2O, and they've given us a state symbol of L, and we're going to form potassium hydroxide solution, state symbol AQ, so KOH. If anybody's wondering how I'm building KOH, it's because I know that potassium is in group 1, so it's always a +1, and I know my complex signs is OH-. Yeah, so it's a 1 and a 1, so it cancels out. So OH-, and then, of course, I've got a gen here, guys. Hydrogen, so it goes into a pair and it's a gas. Now I need to balance it. So 1 potassium, 2 hydrogens, 3 hydrogens. Awkward. Common denominator is 4. So, well, it's actually not, of course, but I can get to 4. So if I double that one to give me more, and if I then double that one, it gets me to 4 hydrogens. That's the key to that bit. Yeah, so now I've got 1 potassium, 2 potassiums. I've just started the process again. Put a big 2 in there to balance the potassium. Start again. 2 potassiums, 4 hydrogens, 2 and 2, 4 hydrogens. The hydrogens there, of course, are the tricky bit. Yeah, and then oxygens, 2, oxygens, 2. I'm done. There's my finished equation. Can I just point out, by the way, that there is a level 7/8 at iGCSE. Yeah, that is considered a higher level one. Most students, and it's actually surprisingly common. Yeah, the group 1 metals in water are a very common equation for Edexcel to ask. And what that tends to mean is that students tend to learn that rather than just balancing it and building it. And I do understand the value in that. It makes it quicker, and when it's so common, kind of says me as well. And I've got no problem with that. I don't learn any equations, any of them. I learn how to build all of them because it's just easier. Next, aluminium oxide. This is, of course, now a level 8/9. Aluminium is a plus. I'm going to do this in total. Aluminium is a plus. It's a group 3, just to check, just to show you where I'm getting that from. Yeah, iGCSE table. So aluminium, everything's moving while I was setting up. Aluminium is in group 3, so that's a +3 group. Yeah, everybody in this family here is in +3. So there's +3. Oxygen, of course, is 2-, and we know that from our periodic table because it goes +1 plus. I'm going to make that thinner as well. Yeah, +1 +2 +3. Going to clean that up a bit. I'm just doing all the reminders, the constant reinforcement. +3. This is +4 or -4. It swaps over, and I always tend to do it in that order. And then, because I know then to drop to 3, and then of course it then becomes -3, -2, -1, and then no charge on this side because they're noble gases. I'll put it up there like that. There you go. So oxygen, of course, is in the -2 group. So I've got, then I'm going to do my little cross and down trick to get Al2O3. There we go. I'm going to add that to nitric acid. I have said to all students, of course, at GCSE, you should always learn your acids. And there aren't many. At GCSE, there's really only 3 acids to learn, but I actually teach 4 because of Edexcel. So we've got HCl, hydrochloric, HNO3, which is nitric, H2SO4, yeah, which is sulfuric, and there is another one at phosphoric as well. I do also tend to teach ethanoic. You will come across ethanoic at the end of. Oh no, you guys don't, being dual award. You guys don't have that one. So those are the only 4 acids that you need to know, and it is worth learning them because they come up so often and they won't give them to you. They will not give you their equations. You just got to know them. Yeah. So HNO3. Right now we need to build our products. I've got aluminium nitrate. This is now a level 9 at Edexcel. Yeah, this is a Love 9. So this is kind of as hard as it gets, really, at iGCSE. Aluminium nitrate. So aluminium is a +3 ion. The nitrate is NO3 1-. Cross them down. Going to need brackets here. I need 1 aluminium, because there's an invisible 1 there. But then I need to put the nitrate ion into brackets. There we go. So aluminium nitrate. So we've got Al brackets NO3 close bracket 3. And it's an aqueous, of course. By the way, all solutions are AQ. That's a solid. Aluminium oxide is a solid. And then, of course, plus water. Now all we need to do is balance it. Yeah. So, okay, so now we've got 2 aluminiums. Let's do this atom by atom. 2 aluminiums, 1 aluminium. So I need to double it. There we go. 2 aluminiums, 2 aluminiums. Right, oxygens. Oxygens are going to be messy. Let's do. Yeah, I mean, we can do options. There's 6 on that side and way too many on that side. Let's right now, this one is a level 9 because you have to deal with nitrate ions. Now, students don't like the complex ions, but just remember that the complex ions remain as complex ions, so you can treat them as single entities. So I have 1 here, but I have 3 here. So treat the nitrate ion as an individual. So if I put the 3 there, that now gives me 3 nitrate ions. And I now have, oh no, I tell a lie. I've got 6. That's a nightmare. Let's try that again. You can now see why this is a level, such a higher level question. So that's a 6 there now. That balances for the nitrate ions. And that will probably now finish off my options in hydrogens too, almost. 6 hydrogens, 2. So I need to triple that, so that gives me 6. Right, that's probably now going to add up, isn't it? Yeah, 2 aluminiums, 2 aluminiums. Oxygens, I've got 3, but I'm not going to use those because they're the nitrate ion, and I don't want to use those. I want to keep those as my nitrate. So 3 oxygens, 3 oxygens. Hydrogens, 6, hydrogens, 6. Nitrates, 6, nitrates, 6. So there's my final answer. Guys, that is very, very higher level. Now, just to tell you how things change from GCSE to A level, that question is very much an A-level question, but they would give you it in complete words. So they'd give you that in a, they wouldn't tell you what the products were. They would just say aluminium oxide plus nitric acid, write the equation. So it's not very complicated because you learn your rules of the equations. You know, if you add an acid and a base, you're going to get salt and water. So it makes things a little bit, I just wanted to kind of like open your eyes to that. I'm happy to show you some of those at a later date if you want me to. Okay, next one, sodium hydroxide, NaOH, got to know that one. Plus nitric acid. This is going to be really good reinforcement of our acid symbols. So this is aqueous, of course. This is aqueous. There we go. Sorry about that long A. There we go. I'm then going to form sodium nitrate. Sodium's a +1 ion. Yeah, Na plus. And the nitrate ion is NO3 minus. That means they just cancel out. So NaNO3 plus water. This one's easier. Balancing slightly more straightforward. Sodium is 1. Sodium, I'll put on my state symbols since people are going to whine about it. Yeah. Sodium 1, sodium 1. Now, I'm going to do the nitrate ion again. Nitrate ion 1, nitrate ion 1. That makes sense. Right, oxygens 1 and 1, hydrogens 2 and 2. So it actually already balances, which is really nice. Much easier, but still at the medium level. Still challenging that. Next, magnesium solid. So that's just Mg. It's not in a pair, of course, because it doesn't end in ene or gen. Yeah. And then I'm going to add silver nitrate to it. You've just got to know this one, AgNO3. That's because silver is always a +1. So I'm going to form magnesium nitrate. Oh, I'm going to build magnesium nitrate. Yeah, magnesium is in group 2 of the periodic table, so it's a +2. Yeah, it's in a +2 one there. There it is. Yeah, and then I've got my nitrate ion, NO3 minus. Crossing down, going to need brackets again. Yeah, Mg1 brackets NO3 2. Yeah, tricky. Much harder than the ones at the start. Now, guys, these, I don't want anyone to feel like if you really struggled with these, I can give you more of them to practice. They do take practice. You're not going to get this overnight. You're not going to get this in 10 minutes. Chemistry is a language, and you have to learn to speak it and write it. I then get silver, Ag as a solid, and balance it. So 1 magnesium, 1 silver, 1 silver, nitrate. I've got 2 nitrates. 1 nitrate, double it. Right, I've changed the silvers, of course. So now 2 silvers and I'm done. Yeah, it does take practice. And I promise you, after a while, the penny will drop and the fog will clear. And all of a sudden you'll be like, oh, actually, it's not as bad as it looks. It's not as complicated, but because there are rules that govern everything. It's a language that has very, very, very distinct and solid rules, which means it becomes much easier and you pick it up very quickly. But it takes practice. If you don't practice it, you won't get it. Magnesium solid appearing again plus carbon dioxide. Oh, that's a great. By the way, this is an amazing demonstration. Magnesium burns in carbon dioxide. It's incredible. It's an amazing thing to see. It spits out solid carbon as well. And look, solid, both solids coming out. Fascinating reaction. Needs to be balanced. So the magnesium 1, carbon 1, 1 oxygens 2. All right, I need 2 of those to balance my oxygens, 2 magnesiums now, and there's my finished equation. Let's go to the next one, ammonia. You've got to know this one. I hope everyone here knows that ammonia gas, this is one of the most important chemicals in the history of mankind. If we hadn't invented how to make that, then we wouldn't have 7.5 billion people on our planet. We'd have a measly billion. Yeah, ammonia is used then to make artificial fertilizer, which means we can grow more plants. So ammonia is NH3, just got to know it. Yeah, gas plus oxygen gas, that's interesting, plus nitrogen. Oh, another gen appearing there. If it's in a gen, then it's got a G after and it's in a pair. Yeah, and then water, balance the equation. So 1 nitrogen, 2 nitrogens. Let's balance that. There we go. 2 nitrogens, 2 nitrogens, 6 hydrogens. 6 hydrogens, needed a 3 in front. Next, Right, now just check again. 2 nitrogens, 2 nitrogens, 6 hydrogens, 6 hydrogens, oxygens, 3. Oh, that's awkward. Common denominator. Common denominator of 2 and 3 is 6. So if I put that there. Oh, hang on a minute. I can't do that. Oh, sorry. O2. And I'll still trying to bounce. Sorry, I've gone and deleted stuff on my pen. Okay, so oxygens is 3 and 2, right? So, and that is awkward. So what I'm actually going to do is, I'm actually going to do a really sneaky trick here, folks. And you learn this. You don't often, this does get taught at GCSE, and you guys might recognize this. The trick is to do 1.5. The reason being is because oxygen's an element, I can actually balance this with half, but you can't leave it as a half at GCSE. You can at A level. But what you now have to do is double everybody. Yeah, you double everything. So that becomes 4. I'm actually going to rechange that for a different color pen. I want the 2 to be there as well, because I want you to see this and how it functions. It's quite a nice trick, this. That's going to become 4. That becomes 3. That becomes 2, and that becomes 6. And now it all balances. This half trick does require practice. You should never put a half in front of anything that's anything other than an element, because otherwise you're going to end up with half atoms, and that doesn't really happen. Okay, next. Hydrochloric acid and right, so these are now meant to be the hardest on the sheet. Hydrochloric acid, of course, HCl. Aqueous, all acids are aqueous. Plus magnesium metal, and they haven't told us the outcome. This is what makes this more tricky. So this one's going to form magnesium chloride, metal plus acid, salt, and hydrogen. So the salt is magnesium chloride, the acid decides the salt, and I also get hydrogen gas. That's one of the rules. And you guys should have been given these already. Metal plus acid gives you salt and hydrogen. MASH, one of my year 12s a long time ago invented MASH. I didn't invent MASH. Let's balance it. 2 hydrogens, 2 hydrogens, 2 chlorines, 2 chlorines, and it actually balances at that point. Let's put our state symbols in. Magnesium is a solid. That's going to be it. All salts are aqueous. No, that's not entirely true. Bad sentence. Shouldn't say that. Most salts are going to be aqueous. Nitric acid, HNO3. It's an acid, so it gains aqueous. Plus potassium oxide. I started writing it on the plus, that's funny. K2O. I'll show you how I built that. And yes, I know that some students often ask me how I do it so quickly. You get used to doing it after a while. Yeah. So I've got 1 of those and 2 of those. K2. The 2 comes down, the charge vanishes, so it becomes K. The 2 appears, and then the 1 appears, but the 1 doesn't ever make an appearance, so K2O. I'm going to then form potassium nitrate, which is KNO3. If anybody's wondering how I got KNO3, it's because potassium is a +1, nitrate is a 1-. They both cancel out, so it just comes together, 1 to 1. And then, of course, acid plus metal oxide goes to salt and water, another rule you should have been given already. And that's, of course, going to be aqueous because it's a salt, and that's going to be a solid. Potassium oxide is going to be a solid if it's not in water. Okay, balance it. Hydrogen 1, hydrogen 2, balance that. Next, nitrate 2. Oh, only 1 nitrate. Let's balance that. So 2 hydrogens, 2 hydrogens, 2 nitrates, 2 nitrates, 2 potassiums, 2 potassiums, 1 oxygen, 1 oxygen. It all now balances. And we're done. If you ever find an equation that doesn't balance, you've probably got a formula wrong, most likely. Last one. Oh, this is an unusual one, by the way, because now we get an insoluble salt. Lead, but you don't need to know this one, I don't think. Lead nitrate, PB brackets NO3. Now, if you're wondering how I've built that, it's because it's told me that lead is a +2. It doesn't have to do that, actually. All lead's a 2+. Yeah, and nitrate is NO3, 1-. Cross them down. I'm going to need 2 of those and 1 lead. PB1, but even though it doesn't appear, then I have to put the nitrate into brackets. But the 1 doesn't need to appear, so we just get rid of it. Yeah, so lead nitrate, potassium iodide, Ki. Yeah, if you're wondering how I built Ki, it's because potassium is in group 1, so it's a +1. There's potassium at K+. And iodide is in group 7, so it's in the 1- group. Yeah, so that's just going to be K+ and I-. It cancels out, so it just becomes Ki. Yeah. Next, swap them over. Just swap the metals. Yeah, I'm going to form potassium nitrate, KNO3. If you're wondering how I built that formula, and I did, it's because K is +1 and nitrate is 1-. It just cancels out. So KNO3, and then I'm going to form lead iodide, and of course the 2 is going to remain. So it's going to be PbI2. I'll show you how I built that. Pb is in a 2+, iodide is in a 1-. crossing down. The 2 drops down to the iodide. Now I need to balance it. These are, by the way, can I just point out that these equations at this stage, these ones here they are level 9, but in reality, you won't get ones this hard at GCSE. This is actually beyond GCSE at this point. This is actually AS chemistry. It's actually AS Chem, A-level chemistry. And it's a grade CD. That's where you're actually now at. If you have managed to do those, I need to balance the last one. I haven't balanced that yet. 1 lead, 2 nitrates, 2 nitrates. Next, 1 potassium, 2 potassiums. Okay. Next, 1 iodide. Won't let me erase. 2 iodides, 2 iodides. Oh, we're done. It works. We're finished. That's nice. So those are the final ones. That brings us to the end of the homework. I do know. Do you know what? It's funny actually, because I'm very aware that I haven't taught you guys for very long. But I do see the value in doing these exercises. I have dozens of these things. That brings us to the end of the homework. Let's total it up now at the entire sheet, because it was a long homework, this. It was a separate one. The other one was out of 10. This one, of course, is going to be, if you've got the 1, 2, 3, 4, 5. Yeah, 5 there, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 in total is out of 15. I'd love to know how you guys got on with that. That was a very challenging exercise. So it's out of 15, the equations homework. I know that some of you guys will have paused this. That's absolutely fine. Take your time. There's no rush here to fill in the data. Yeah, no rush at all. Be nice to see how people got on. And now we've got a good half an hour on moles, which would be really nice. I have a bit in my coffee if I can find it. How did you guys get on? Somebody say something on the chat. It'd be lovely to know how you found that. I've got a feeling that you guys are going to ask for more homework here, aren't you? You're going to ask for more examples of these, and I'm happy to provide them. I do know that these take practice. And what tends to happen is students start off at the beginning and they kind of go, oh, I can't do it. And then by the end, they're kind of going, oh, actually, I kind of getting used to this. But then what happens is they then don't do any more practice. And then all of a sudden, they really struggle again. Let's see how you got on. Oh, well done, Adri. That's a great result, Adri. Really pleased with that. Really, really pleased. That's great. 13 is a solid result. Oh, look at that. Amber, I'm super impressed, Amber. You smashed it. Well done. That's great. Really, really pleased, Amber. God, you guys have done amazing. That is a hard. I feel like the longer questions should be worth 2 marks. Ha! Kate, that's really funny. Kate, in reality, that's a really good point that you're making there. So, okay, if I'm honest with you, Kate, the only actual ones that you're going to get at GCSE are the first 5. The chances of you getting these will be there. These are iGCSE, GCSE. These absolutely, they're just balancing equations. These are said to be common. Yeah. These are, in fact, every paper. Yeah. Every paper has balancing equations, usually 2. Just so you know, these ones here do exist. This task 2, this group here, these do exist at iGCSE, but they're rare. Not all years have one, because the level is so much harder, and they will be worth 2 marks. And the marks are split, just so you know, the marks are split. So if I was just to choose one equation, let's choose this one. Let's choose this equation here. The marks would be said that if you've done the symbols correctly, you gain 1 mark. If you've balanced correctly, you get the second. So that's actually how it would be split in reality, but I don't really want to do that. It just makes the marking more tedious. And in reality, there's no point. When you get to A level, it becomes 1 mark. So at A level, and these all then, by the way, these are so incredibly rare at GCSE. I can't remember the last time I saw one where it was actually this hard. Yeah, these are really AS level chem. Yeah, they have appeared and EdXL have done it, but they're so rare I don't tend to worry about it too much. But when you get to A level, all equations are worth 1, and sometimes they can become ethically hard, and you should treat them as such. Because in reality, imagine writing an English sentence and then marking you on the spelling and then the syntax separately. You know, they wouldn't. It's just, does the sentence make sense? You know, you just can't really separate them out in my eyes. I do think it's just, you can't. Yeah, it's really lovely to see some great results here, guys. Well done. Bo, Yang, and Ryan, I need you to fill out your data. Can you both say okay on the chat for me that you will do this today, please? Bo, Yang, can I have your data, please, by the end of today? Come on. Thank you, Bo Yang. I really appreciate it. You know I do. And it's only because I love you, Bo Yang. It's only because I love you. Ryan, are you going to give me your data today? Oh. Ethan, well done on that equations work. Smashed it. 2 14s. Can I just point out, even 11 is a great mark. Chimun, it'll get better. The more you practice, the better this gets. So I'm really happy with that. Is Ryan still in the room? Ryan. It's nice to see you guys filling in your data. It does make me happy. It does make me happy. It just gives me a bit of instant feedback. And you guys can also see how you've got on. It's awesome to see that everyone smashed presented composition. Amazing, that. And you guys have done so well. You've had such a great start of this. I'm really pleased. Okay. I'm going to leave you guys to fill in data. And we're going to start moles properly. Okay. So, guys, iGCSE moles. So this is moles, lesson 1. Moles, L1. So I need you guys to, number 1, need to do a learning objective here, guys. So my learning objectives are, we need to understand function of moles. Why did we invent them? Yeah, what is their purpose? Yeah. Number 2 is be able to calculate moles. I'm going to put in brackets N equals grams over rams. So I'm giving you an equation there, folks. Yeah, this is moles. I'm going to put this into words as well. Yeah, same equation. Moles equals grams over rams. Relative atomic mass. Or, by the way, it can be rums, of course. Relative atomic. I'm just translating it into words just because I feel at times that some students like the word version. I of course say it every time. It's also nice to see how things are translating across in symbols. The symbol for moles is N, a lowercase n as well, not a capital M. Capital N is newtons. Yeah, calculate moles. And then I need you guys to be able to rearrange equation. Okay. And guys, I don't like triangles. I really don't like triangles. I know that some of you, your teachers teach you triangles. I hate them because it's not good. It's not good for me to set you up. Not good to set you up with a triangle and then you just take on A-level chemistry and not be able to rearrange a basic equation. It's a nightmare. It's like me having to reteach it all over again. Okay, so what is a mole? So the mole. Okay, so the mole it's a mole. It's a mole. Check out my mole. Oh, I'm so sad. So the mole. Now the problem is, guys, there is a difference between a definition and how to actually explain what a mole is. So the first thing I need to do is I want to give you the definition of this. Yeah. So 1 mole. I know, what a nightmare. Oh, do I want to do it that way? No, I don't. So moles. So let's do bullet point number 1. I'm going to make my pen a bit thicker now. Bullet point number 1. Oh, that's too thick then to write with. So 1 mole is, make that clearer, is a fixed number. 1 mole is a fixed number of particles. So at this point, people go, I don't get it. I totally agree. I don't get it either. So what does this mean? Yeah, what does this mean? This means that 1 mole of water, 1 mole of water has the same number of particles, same number of water molecules. I'm going to switch to molecules now because it's covalent and I can. Same number of molecules as 1 mole of carbon dioxide, of CO2 gas, if you wish. This has the same number of particles. The number of particles is the same. It's a fixed number. Now, if anybody's wondering what that number is, number of CO2 molecules. Don't worry about the switching between molecules and particles. I don't need to worry about that too much. Yeah, particles is the word that generically covers atoms and molecules. Yeah. However, we realize that these are molecules, H2O. 1 mole of H2O is a molecule because it's covalent. Yeah, and that's liquid, of course. So people often ask me what that number then is. So what does this actually, what's this number, what is it? It is 6.022 times 10 to the 23 particles, of molecules. So that would also be 6.022 times 10 to the 23. Now this number, and this again, once again, is also molecules. So this number was discovered first by Einstein, amazingly. And then it was improved, it was kind of fine-tuned by a guy called Avogadro. This number here is called Avogadro's number. Sometimes called avocado's number. Well, love a good avocado. Now, people often go, wow, it's a really big number. This number doesn't matter. You just need to, what I need you to know is that 1 mole of anything is the same. There is something more useful here. Now, by the way, I know for a fact, at this point, there are going to be students going, hang on, I don't quite understand this. It will become clearer the more you use it. And if anyone's got any questions, please ask it on the chat. But 1 mole is a fixed number of particles. If I have 1 mole of Toby's, which is me, I would have that number of me's. If I had 1 mole of Kate's, I'd have that number of Kate's. And yes, it is a big number. That number was actually discovered about 150 years after the mole had been invented. They didn't know what the number was. They just made it up. And it's very clever because there's another really important fact we need. So the question is now that students often have is go, hang on a sec. I'll scroll down. Hang on. So how do you count particles? How do you count a particle without knowing that number? And this was genius. We know, and by the way, I'm trying to slow down a bit here. We know my periodic table is awesome. This is one of the most amazing things you would ever be given. Yeah? And let's just take 4 random elements. Yeah? Let's take manganese. Let's take sulfur, yellow sulfur. It's always a good one. Let's take carbon, so important, so important. And let's take hydrogen. Hydrogen, carbon, sulfur, and manganese. So what do these look like? So hydrogen is the smallest of all the atoms. Tiny! And each atom weighs 1. That's what the top number says. This is the mass number. Yeah? The total number of protons and neutrons in an atom. Yeah, it's nice to remind ourselves of that. Total number of P plus and N's. Yeah? It's always good to remind ourselves. But we know that hydrogen weighs 1. Agreed? Next we can go to carbon. Now carbon is bigger. A carbon atom weighs 12. Yeah, it's got 2 numbers, we know. But the bottom number is the number of protons. This is the atomic number. This is the atom's actual number, the element number, atomic number. But this is the mass number. Yeah, this is how much it weighs. Agreed? So carbon has a mass number of 12. So carbon weighs 12. And it's a bigger atom. Right, next, we then went to sulfur. Sulfur's bigger again. And sulfur, atomic number 16, mass 32. So we can then say, so the sulfur atom has a mass number of 32. It's heavier. Oh, hi, Sian. Sian, I'm just doing a year 10 lesson on moles. It's nice to see you. Year 10, this is one of my amazing year 11s. If you ever have any questions regarding chemistry, you should ask Sian. She's an amazing chemist. The last atom we chose was manganese. Manganese was the biggest. Oh, I don't even know my manganese number. Yeah, I think manganese number is 55. Eek! Oh, and 25. Didn't know the bottom number. I just screamed like a girl. That was amazing. Here's my mass number. That's what I'm talking about today. But I think everyone in this room, everyone here, thanks, but no. Everyone here would agree. I'm just going to get rid of that for a minute and put this up here. Everyone here would agree that all of these atoms have different weights. Now, if I wanted to measure out one of everything, yeah, I want to have I just want one of each of them. Everyone here would realize we can't. The first thing to say is, number one, you can't measure out, I'm going to underline can't measure out one atom. Yeah. The second thing is that you can't count atoms. They're too small. But what you can do is weigh out their atom's mass in grams. So what they did is they said, I am going to weigh out, I am going to weigh out one. I should have chosen a different element other than hydrogen. It's a bit of a nightmare. I'm sorry about that. I've made a mistake there, folks. Hydrogen is a problem because hydrogen travels around in pairs. That's a problem. That it's a gen. Yeah, hydrogen. As soon as I see that gen, I'm like, ooh, travels around in a pair. That's going to be a problem. So because hydrogen travels around in a pair, its molecular mass is 2. Yeah, each hydrogen weighs 1, and I've got 2 of them, so it weighs 2. So I'm going to weigh out 2 grams of hydrogen. I'm also going to weigh out 12 grams of carbon, 12 grams. I'm then going to weigh out 32 grams of sulfur, and I'm going to weigh out 55 grams of manganese, 55 grams. And if I do that process, if I weigh out on a set of scales, yeah, if I weighed out, I'm going to use carbon and sulfur as my example. If I put 12 grams of carbon on this side, yeah, 12 grams of carbon and 32 grams of sulfur on this side, everyone would realize that the scale, of course, the scale would be tipped in this direction. But here's the amazing thing. I would still have the same number of particles. Because each particle is heavier, so if I then weighed out, let's do another example of this. Let's do this. Let's have a set of scales. And I want 3 moles. Let's just choose a random number. 3 moles. Now, what that means is we're not going to worry about Avogadro's constant. What this looks like is 3 particles. We can just treat them as singular particles. So I'm going to put on this side 3 particles of each. I'm now going to choose 3 different elements. Yeah, I've got, would everyone agree, I have 3 moles on each side. 3 moles of particles. Yeah, 3 moles and 3 moles. And what we now do is we now choose our person. Let's do manganese. Mn55. Shouldn't have gone for that. Mn55. Partly because it was my heaviest. Yeah. And then I'm going to choose somebody else from my table. Let's go for mercury. That's always a fun one. 201. Hg201. They're very heavy. Yeah. So I now have the same number of particles on each. I have 3 moles, but they're going to weigh very different amounts. On this side, the total is going to be 165 grams. Because one mole is equal to the AR or MR in grams. That's super handy. Yeah? Super handy. Yeah, 1 mole is equal to AR and MR in grams. And in this case, we're doing AR because we're using atoms from my table. What would the mercury's 3 moles weigh? A lot more, 603. I'm just adding them together if you're wondering. Yeah, 201 times by 3. But that will be 3 moles. I've got the same number of particles, but the particles weigh very different amounts. Now, that is the understanding behind the concept. But in reality, we now need to apply this in some questions. So, you need one equation. Number of moles, N is moles, equals grams over rams. Right, let's put it into, I'm actually going to write, not that really matters. I think you guys get this. Yeah? So, let's just do some questions. I've got 5 minutes. Question number 1. So, I want 15 grams of, let's choose someone. Choose somebody on my table. Let's go for boron. I like it. Now, boron is 11. Of boron, 11. Right. Input my data. What do I have? By the way, question number 1, 50 grams. How many moles? How many moles? By the way, that's the same as saying how many particles? Yeah? How many moles? Question mark. Right. Number of moles is grams over rams. You always write that down because it helps get it into your head. Right, I'm after N, so just insert my data. How many grams do I have? 15 grams. What's my relative atomic mass? Boron is 11. So I'm just going to run that straight through my calculator. There we go. 15 divided by 11. And I get 1.3. And it should always be the 3 significant figures, 1.36 moles. And I'm done. If I now wanted to know how many particles I had, I could multiply that by Avogadro's constant, and I will actually get the number of atoms of that I actually have. Isn't that cool? Isn't that amazing? You don't need that, though. Don't worry about it. No. Next, question number 2. Question 2. I'm going to make this one slightly trickier. I'm going to do 30 grams of hydrogen. Notice I've given it to you in words. There's a reason for this. Because the first thing we need to do is, right, I've been given grams, and I want 30 grams of hydrogen. Moles? Question mark. Number of moles is grams over rams. Right, I'm after him, put in my numbers. Therefore, number of moles equals 30 over, right, how much does hydrogen weigh? Hydrogen travels is on the periodic table is 1 and 1. Well, the mass number there is 1. That's the most common mistake students will make. In reality, we know hydrogen travels in pairs. So it's actually going to be divided by 2 because each hydrogen weighs 1, which gives me 2 grams. 1 mole, is 2 grams. So I'm going to have, I've now got 15 moles of hydrogen in 30 grams. That's a lot of particles. Suddenly start to realize that there isn't a lot of particles in hydrogen because they're so light. Next, let's do another question. Question number 3. Let's do a compound. Let's do carbon dioxide. Yeah, let's do 100 grams of CO2, of carbon dioxide. Moles? Question mark. I'm just trying to speed things up. We've only got 3 minutes left. Number of moles is grams over rams. You always write it down. There's usually a mark for the equation, by the way. Number of moles equals 100 grams over how much does carbon dioxide weigh? Right, so carbon dioxide, carbon is 12, but it's joined to oxygen, which weighs 16, but there are 2 of them in it. Total of all of that is 44. So over 44, the weight of CO2. Right, so 100 divided by 44, and I get number of moles is equal to 2.27 sig fig mole. And we're done. This is not a complicated process. Yeah, this is not complicated. This is all we're having to do is use a very simple equation, but what you realize is you're tying in several steps. You need to understand, you need to know the equation, and you need to understand what the relative atomic mass is, or molecular mass is, and you need to be able to calculate it. Hence why you can't do this lesson without the relative molecular mass lesson. Without this lesson here, which is not coming up, without this lesson, you can't do moles. And that's why. Right, guys, I'm going to leave you be right there. Now that we've covered just a couple of questions, go back to my, Bo Yang, thank you, Bo Yang. Ryan needs to put in his data, but thank you, Bo Yang. Zihan needs to put in his last 2. Yeah, I'll keep an eye on those. I'll go back to me. There we go. Guys, I will leave you be today. Have a great rest of your day. I will post it on the classroom some questions on working out moles. They'll also do a bit of rearranging of that equation. If you struggle with it, just pause and then you can go through it and then I'll submit some more another time. But I will post those for you for Thursday, I believe. Or Friday. Thursday. Yeah. I'm just checking the timetable. It is for Thursday. I'll post those on the classroom now, folks. Guys, go and have a great rest of your day. It's been awesome to see you, Year 10. Take care. Be safe. Bye now.